you have image?
Let's see if it's sold.
Okay, you're good to go. Thank you. Okay. Thanks. I think the technical issues are now solved. So, thanks again, everyone, for being here. So I'm going to talk today about Apache Beam. Apache Beam is a framework for data processing that runs on top of several platforms, and it's especially meant for doing streaming analytics. So Javier already introduced me. My name is Israel. So I work as a cloud data engineer in Google Cloud, helping customers doing data engineering on top of Google Cloud. A lot of the work that I do is actually helping customers with Apache Beam, and particularly Dataflow, which is our runner for Apache Beam. So Apache Beam, what is it? Apache Beam is a framework for data processing. It allows to run data pipelines, like Flink, like Spark, like so many other big data systems. It has two main features. The first one is that it's an unified computing model for batch and streaming. Any pipeline that you have written in Apache Beam for a batch use case, you may easily use it in streaming as well. Okay, so the same code, you reuse all that code, and you have to add some small additions that we're going to talk about in a bit. And the other main feature is that it runs everywhere, and you can write your pipeline in many different languages for some definition of everywhere. So you can write your pipeline in Java, in Python, in Go. You may also run your pipeline in any of the programming languages of the Java virtual machine. For instance, so I have here highlighted Scala because there's a framework called Shio, done by Spotify, on top of Apache Beam for, let's say, Scala native development of pipelines. So you don't have to use like a Java looking code in Scala. So it's a functional code. There are lots of people using, for instance, Kotlin also on top of the Java virtual machine with the Java Beam SDK. So that's about the programming language that you may use. And you may run a Beam pipeline on top of runners. Okay, so there's a direct runner for local running and local testing of pipelines. It's not meant for, let's say, to be used, let's say, with real world use cases. But then you can run your pipeline on top of Dataflow, on top of Flink, or on top of Hazelcast, Spark, many different runners. So basically, when you write a pipeline in Apache Beam, you are not tied to the platform where you're running. So you may move it to different platforms, with some minor comments. So Apache Beam is a theoretical model for computing. Not all the runners implement the model, let's say, to the same degree of extent. Okay, so right now, as of now, so I would say Dataflow and Flink are probably the ones that are covered, like fully covered. Other runners may have some gaps. Silly example, Hadoop. You may run a Apache Beam pipeline on top of Hadoop also, but you cannot run streaming on top of Hadoop because it doesn't support the streaming. No? So it also depends on the capability of the runner. So what you're able to do with Beam, it depends on the capabilities of the runner. So there's no magic, okay? So if Beam is batch and streaming, but if your platform doesn't support streaming, for instance, so you cannot do streaming. So let's talk about streaming. What's the problem with the streaming? It's extremely interesting. So in streaming, you are getting data, a lot of data, continuously. There is no beginning and there is no end. Okay, so you cannot know in advance where are the boundaries of your data. Okay, and it's coming continuously from many different places. Think, I don't know, like you are designing a mobile application for a game or whatever, and people are using it and sending events to your systems every once in a while. So because the application is deployed in the wild world, data will come, who knows how, okay? So it will come out of order. So some users will be, I don't know, in the underground and without the phone coverage, still attempting to send in events, and then they will send the events late. Like, for instance, here, let's see if I can put the pointer. So so this is data that is supposed, okay, now, so this is data that is supposed to be produced around 8 in the morning, okay? Maybe there are network latencies and so on, but more or less you get it around 8 in the morning in your system, okay? So this is the time where you're seeing the data in your system, but for whatever reason, you may also get very late data, okay? And depending on what you want to do, you may want to process this data as it was produced, not as you are receiving it, okay? So this is actually the problem with micro-batching. So I remember when I started hearing about the streaming in the first days, many years ago, a lot of people said, Spark, I don't like it because it does micro-batching, doesn't do real streaming. I had no clue what they meant. It's like, well, you have to group things, no, to process it somehow. So if the data is infinite, you will need to process it. The problem with micro-batching, which is not happening in Spark anymore, so this was really like ancient times. The problem with micro-batching is that you are doing the batches as you see the data, okay? And then you may have the data that belongs together in buckets that are separate. Like, for instance, this was data that was produced at the 8 in the morning. If you are doing buckets of 1 hour, so well, you may capture here this message, but then if you have late data, you will capture it in a bucket that doesn't belong. Let's say that element doesn't belong with the rest of the elements there if you want to process them together. So you need to solve this problem of lack of order in streaming. Okay? And this is what you can easily solve with Apache Beam. Let's talk about the watermark. There are many ways of doing stream processing. One of the most popular is using a concept of watermark. There is no one dimension of time. There are 2 dimensions of time, at least. There is the event time, the moment in which the data was produced, and there is the processing time, the moment in which you see the data. They will never be the same. They can be really close sometimes, but it's not. You cannot guarantee how close or how far you are going to be from that moment. Okay. So when we put time in 2 dimensions, okay. So the ideal is, for instance, like this straight line in blue, for sure. This zone is impossible, okay? You cannot see data before it's produced, or not yet at least, okay? So according to the laws of physics, okay? So, but then what most likely what it will happen is that you will have some delay, okay? Sometimes it will be closer to the ideal, sometimes it will be farther from the ideal, okay? Okay. So, and you need to take this into account, okay? So let's see an example that might be a little bit more telling. Okay, so Star Wars. Okay, so have you ever watched a Star Wars movie? So Star Wars were released out of order. Okay, so the first movie was Episode 4. This is purely streaming. This is what happens in streaming. Okay, you are expecting events. Okay, the beginning of the session, in the middle of the session, the end of the session. Okay, and then you get end of the session, middle of the session, beginning of the session, and you need to reorder things, okay? Depending on what you want to do, you may need to reorder, okay? If you don't care, like, look, I don't care. I just want to count how many movies per year were released, okay? Well, you don't need event time, okay? But if you want to reconstruct the story, okay, who did what before or after, what happened, so you need to actually be able to reconstruct that time, okay? So the time where the movies were released, it's processing time. Event time is the time in which actually the events are happening, okay? So, and this is the kind of problems that we can solve using Apache Beam or Flink or many other streaming systems. Let's see how we can deal with this. The classical way is using windowing, okay? Windowing is grouping things based on temporal properties. When we do a data pipeline, we need to solve one question, which is what we are going to compute. But if you want to do this in streaming and group things based on temporal properties, you need to answer 3 additional questions. Where, when, and how. Let's see some details. The what, this is easy. We are going to be aggregating, okay? So this is Java code. I'm using Java here as an example. So it's the Apache Beam API. I haven't entered into details. There's a link at the end with more details, okay? So don't mind the details right now. So we're aggregating things together. So this is what we are happening. We are not doing any kind of temporal-based logic yet, okay? We're just aggregating stuff together, okay? So we're summing up all the numbers here, okay? So this is the operation that we're doing. Same as in batch. This is in batch, okay? So imagine that we are getting this batch, okay? The problem is when we are working in streaming, we don't see the full data at once, okay? And we need to produce output at some point, so we cannot wait forever. So we need to decide how to group things together. So for instance, here we're gonna group things in windows of 2 minutes, okay? But the windows of 2 minutes are not in processing time. They are in event time, okay? For instance, so here, this message here, so this message here, it's we see it around 12, okay, and we put it in the window of 12, okay. But this message over here, so this was received between 12:08 and 12:09, okay, and we are able still to attribute it, to assign it to the window between 12 and 12:02 in event time, okay, because, well, so we can wait for late data and put it in the right window, despite the message being quite late compared to the processing time, okay, and same with the rest of Windows. Now the question is, okay, good, so you're waiting until 12:08, so what if your message shows up at 8 p.m.? What do you do, like 8 hours after? So we need to do another decision, okay? So we have already made the decision of how we're gonna group things together. Here is with easy windows. There are more windows in Apache Beam, not entering into details right now, but now we need to decide how long do we wait, okay? So we are gonna wait until the watermark, okay? The watermark is this relationship between processing time and event time that in the case of Beam and depending on the runner is calculated and estimated on the fly as data goes through our pipeline, and this curve is estimated, and when you trespass the watermark, you have a certain degree of guarantee that your data is complete, okay? A certain degree of guarantee, okay? It cannot be guaranteed because, well, so the future cannot be known, okay? So we cannot travel in time, okay? So here, for instance, so we are processing data and the watermark, and the 9, this number here that we were processing before, now it's left out of the window. So what does it mean if we are processing data? We were summing up numbers, that 9, we are not counting it. As soon as we see it in our pipeline, it will be dropped, like lost, okay? So the pipeline will ignore it, okay? And it may make sense, okay? So you cannot wait forever. At some point, you will have to stop and move on, okay? But maybe you want to take it into account, okay? So maybe I don't know, like this is a billing, invoicing thing, and like every penny counts, okay? So then you need to process it. Well, you have to take yet another decision. How we are gonna wait for late data and how we are gonna actually update the data, okay? Here I'm summing numbers. It's easy. Commutative, associative, really no big deal, okay? So I can do it, like say, I can do it like a monoid in big data processing. So I can just take the aggregation, the previous aggregation, and keep aggregating. I don't need to keep all the numbers that I have seen so far. So it is easy. In other cases, for any non-associative, non-commutative operation, so you may need to have actually full data to produce an update, okay? And if we are working in streaming, maybe you don't want to accumulate all the data, okay? Because that will increase the amount of resources that you will need for your pipeline. It will have impact in performance, latency, and so on. So here we are accumulating because the operation allows it, and we are actually waiting for late data, okay? So now we are waiting for late data, but we don't want to wait forever. We want to have some numbers, okay? So we are actually producing several outputs per window, okay? So like, for instance, here, continuing with the first, so when the watermark is trespassed, so we produce an output, okay? And then when we see the new number, so we produce the output. We produce it really late, okay? But well, so this is, so we cannot make magic, okay? So this is when we see the data, so we cannot process it earlier than this, okay? We may actually decide to produce data, some output, even before the watermark, because the watermark can be really slow. It depends on the pace of the updates of the data. If for whatever reason users are sending your data with a lot of lateness, the watermark can progress really slowly, okay? And so the watermark, how you produce output is always a trade-off in streaming between completeness and latency. You need to make a decision, okay? So here we put an early trigger, so we're producing output soon, low latency, but it's incomplete because, well, so later on we're gonna keep seeing numbers until the watermark. Good. So basically, this is streaming in Apache Beam in 10 minutes. This is a lot of information explained very quickly. If you want to get deeper, there is this example here, okay? So in Java and in Python, so it's available in the 2 languages, and you can see everything that we have seen in the previous slides with all details, okay? And you may run this locally if you want. So you don't have to have like a environment, so like a cloud environment, a cluster or a stream processor or anything like that. So it may run locally with some synthetic data, made up data. Okay. Now, this is the classic way of doing streaming in Apache Beam. This has been around for years already, okay? So this is the same model that is implemented in Spark. It's the same model that is implemented in Flink. So they are all kind of similar. There are other things that you can also do in Apache Beam in streaming. Like anything that you can do in Apache Beam, you can also do it in streaming. And I'm going to highlight here a couple of those, okay? I'm leaving out a lot of stuff because, well, so time is limited. And leave it out, for instance, SQL. So that was a great talk by Timo focusing on SQL. So you can also do SQL in Apache Beam if you want in streaming, okay? So similar examples to what Timo did. And you can actually run that on Flink if you want, okay? So it may make sense if you, well, I don't know, if at some point you want to move away from Flink to Dataflow, you want to move away from Dataflow to Spark, so in order to have this portability. One thing that you can do in streaming is stateful functions. And stateful functions are very interesting for windowing, between quotes, that doesn't depend on time. Very typically, I work with customers, it's like all this windowing triggers things is super interesting, but look, whenever I see a message of this type, I want to have all the messages that I have seen so far in a group and do these calculations. And I don't care about time, okay? I don't care about grouping things in time. I want to group things by some logic, okay? I'm going to give you a predicate. You pass a message. If the message fulfills a condition, I want to close the previous window and start a new one. How can you do that in Apache Beam? You can do that with stateful functions, okay? Stateful functions, so here we have some input. Here we have a map. It's called a Pardo in Apache Beam, and we do some transformation. And we want to accumulate a state here, okay? So depending on what we see at some point, we do something else. And this is mutable state, okay? In a system like Dataflow, like Flink, like all the systems where Apache Beam runs, having a state, mutable state in a streaming that is computed in a consistent way is extremely difficult, okay? One way to shoot yourself in your feet with systems like this in streaming is trying to keep accumulating state using some kind of external system, okay? Because runners will have, sometimes will have issues, that will be errors, that will be retries, infrastructure will die, you will have auto-scaling. There are all kinds of situations that the runner may want to retract the computation and recompute again, okay? So, and then in all these kinds of situations, having any kind of external system for mutable state, it's complex, okay? It's doable, okay? You may have, and you will have with Apache Beam in any kind of the runners that you can run, you will have this end-to-end exactly once processing, but this end-to-end exactly once processing doesn't mean that your code is going to be executed exactly once. It may be executed more than once, okay? This is what makes maintaining external state to a pipeline complex. But if the state is internal to the pipeline, then, well, so the system itself can, let's say, take care of the problems of reprocessing and maintain a mutable state in a consistent way. So this is what it's stateful functions in Apache Beam. And you can use it for use cases like this, okay? For instance, say that I want to produce windows, between quotes, based on some kind of property. So I keep seeing messages, okay, that I keep processing, okay, and then I keep accumulating the messages in some state, okay. I maintain a buffer, like I keep every single message that I see, and I count, okay, because, well, the buffer cannot, so the buffer must have some boundaries, okay, so because this is local state that is maintained in the machine, in the worker, in the executor where you are running, and the executor will have limited resources. Might be very large resources, but limited anyways, okay? So you keep accumulating, and then you keep processing here, for instance. So typically you can use this, for instance, for batching to call in an external service, but you can also do here, whenever I see a specific type of message, I emit some output, okay? I emit some output, and then I have applied a window. All the messages that I have in the buffer, I tag a new session ID, a new window ID, and then I emit them. I hold them for a while until I see the right message that I need, and then I emit them. There are two problems here. So customers always think that streaming is complex, and they want to get away of all the temporal-based calculations. Okay, it's so complex, so messy. Look, my algorithm is really much simpler, but it is not. So you are in streaming, so you cannot ignore time. Okay, you will have situations in which you will see the messages out of order, and you will have situations in which you not see the messages for a while. Okay, and then you need to decide what to do in these two cases, even if you don't want to. Okay, what happens when I see out of order? You may say I don't care. Unlikely, but well, in some situations might be true. Okay, or you may have to wait like some timer in order to give room for late data to arrive into your code and actually produce the actual output. Okay, so this would be an event time timer. Okay, look, in event time, you are gonna see the messages and order. Okay, so wait 30 seconds, 2 minutes, and so on. And then when you have seen all the messages, is the moment in which you apply the session. That's called an event time timer. And you may have also problems of staleness. Okay, I'm waiting for the end of my session, but I'm not seeing messages. I haven't seen messages in the last 5 minutes in processing time. Okay, the problem with event time is that it depends on the progress of the watermark. But if you stop seeing messages, the watermark will stop advancing. The watermark is always estimated in Beam runners or normally estimated as the timestamp of the oldest message waiting to be processed. Okay, so literally you may stop your pipeline waiting forever for some data that maybe it will never arrive. Okay, so processing time timers solve this problem. Okay, after 10 minutes, like measure with a clock. If nothing comes, I don't care about the watermark. I don't care. Keep going. Okay, so keep going. So data has been lost for whatever reason, and we cannot wait forever. So this is a stateful functions, and it's also very useful in streaming because it allows you to apply logic that goes beyond the temporal properties that we have seen in the previous slides. And here you have some examples and links. The slides are already available through the FOSDEM website, so I encourage you to have a look at these examples. What else can I do in streaming? Machine learning inference. Okay, so there's many ways to do machine learning inference in streaming at scale. Okay, many of those quite expensive. So you can deploy endpoints in cloud platforms with GPUs, with a lot of stuff. Okay, and normally, so those solve a lot of functionality for you, but they are expensive. So what if you want to apply machine learning inference in a pipeline in Apache Beam? Well, you could do that, okay? You could be thinking, well, I can do that, so I can, I don't know, like import TensorFlow, load the model, apply it. So you could do a lot of stuff, okay, yourself. But this is already solved for you in Apache Beam, okay? So you can run machine learning inference with the so-called run inference transform, okay? So we see it here. So right now it has, let's say, out-of-the-box support for PyTorch, TensorFlow, and scikit-learn, with more coming. When you're running in a distributed system and you want to apply a model, each one of the workers in the distributed system will have its own memory. So the Apache Beam runs on top of shared nothing architecture, okay, like Flink, Dataflow, Spark. Workers are independent of each other. They don't share any common state. The state that we have seen before is actually maintained per key and per window. If we apply a per window, it's totally local for the worker, and two workers cannot share a state. But a model, we don't want to instantiate a model if we have 100 workers 100 times, because the model is going to be the same for every worker, right? So the model doesn't change. The model is actually read-only. Run inference solves these problems by having some state that is shared across all the workers, and it's transparent for you. So this is something that you can always implement in a distributed system, but it's complex. This is the problem that is solved with run inference. It's only one copy of the model per, let's say, machine where you're running, okay? So in memory, okay? Because, well, you need always to make an instance in memory to be able to apply it. But if you have, I don't know, like 100 threads, 100 sub-workers, 100 CPUs inside the same machine, you will not have 100 copies of the model, regardless of, let's say, what's the computation model of how the runner is implemented on top of the machines. There will be only one copy in the memory of the machine. So this is the problem that is solved with run inference, okay? So if you want to apply a streaming inference, it's a very convenient way of doing this, with very little code. And depending on the runner, this is a possibility in Dataflow. This is also a possibility if you are running on top of Kubernetes in a runner that supports Kubernetes, like for instance Flink. You can do also hinting of the resources that your transformation is going to need. Okay, hinting of transformations could be, look, this transformation is going to need this amount of memory, minimal. Okay, but hinting could also be, look, this is a step that is running ML inference, so use a GPU for this step, okay? And then the runner will take care of making sure that the step that is run in a virtual machine, let's say, matches the infrastructure hints that you provide through the code, and you will have, like, let's say, different types of nodes for different types of transformations. One of the problems of shared nothing architectures is that all the workers are alike. All the workers are the same. With this, you can have different types of workers for different kinds of transformations, which, let's say, in terms of cost, it's better. I don't like to say optimal, so maybe that's a better alternative. But basically, you use GPUs in the workers where you need to use GPUs. You don't use them in the workers where you don't need to use them. And you don't have to worry about assigning work to different workers. That's actually done by the runner automatically with these hints. Okay. If you want to know more, here you have some links. So I have only 5 minutes left, so I'm leaving the best for the end of the presentation. Great, you look, Israel, you showed some Java at the beginning. Now you tell me ML inference is so cool, but it's Python, right? So it's PyTorch, TensorFlow, scikit-learn, it's all Python. One of the things that you can do in Apache Beam is in cross-language transforms. Anything that you have available in any of the SDKs in any language, you may use it in any other language, as long as the runner supports this. Okay, so it's not supported by all the runners, but it's supported by the main runners. Okay, so basically, run inference may be used in Java. If you want to use any transformation from any language, you have to add some boilerplate code, not so much, but a little bit. This is already done, let's say, for the main transforms that are most popular, or that, let's say, that make more sense to be used in different languages, like a map. Well, using a map from Java in Python doesn't really make sense, okay? Using run inference makes. Using connectors, input-output connectors from another SDK in Python, for instance, makes sense, because let's say the amount of input-output connectors that you have per SDK is not the same. So you may write, I don't know, like to databases in Java and to message queues in Python, but maybe you don't have the same functionalities in all the SDKs. You can use any connector from any SDK, and this makes it quite flexible. Okay, so these are the so-called multi-language pipelines, and basically it means that you can run any transformation in any SDK, and this is implemented because the runner environment is containerized. Okay, so there's a container per language, and there's some magic that makes, let's say, the container communicate between themselves. Okay, and the serialization and the deserialization between programming languages. So this is part of the boilerplate that you need to take care of. If you use things like Apache Beam schemas that I haven't talked about in this talk, so it will be transparent for you. Anything that you have in one schema in one language, you will be able to serialize it, and they serialize it to any other language. So if you follow, let's say, if you follow the Apache Beam customs, it's quite straightforward to use these kind of things. Well, thanks everyone so far for your attention. So here, and almost done. Here are some links that I recommend you to have a look if you want to learn more about Apache Beam. I have covered a lot of stuff in a very short time. Okay, so there's a lot of things behind everything that I have explained here. If you want to know more about all the windowing, streaming, triggers, watermarks, and so on, I strongly recommend you this book. It was released some time ago. You may think that it's outdated. It's not outdated. So let's say this is the same model that is applied in many different streaming systems. And this is not a book about Apache Beam. It's a book about the streaming systems with lots of examples coming from Apache Beam, but also examples coming from Flink, Kafka, PubSub, and many other systems. And it's very interesting. It's my favorite book, one of my favorite books. The other one being the book actually about from Martin Klettman about data-intensive applications. And if you want to know more about Beam, so I recommend you the Beam College. There are lots of videos with lots of details about the things that I have explained here in YouTube. Some of them are actually linked in the slides. for sure, the main site of Apache Beam and the programming guide and all the documentation that is there. And if you want to learn more about Apache Beam, there is also the videos of the Apache Beam Summit, the previous editions. And if you want to participate, if you are here today, so you may be interested in streaming, so the call for papers is open until March 20, I think. Beam Summit will be in June in New York. And, well, I encourage you to submit talks. Well, so this is all. So thanks all for your attention. It's now time for questions now.
Time for one question, maybe?
Yes.
Yeah, this question. So, in the beginning, you mentioned that Beam is running over Flink, but what is added value by Beam itself? Because most of the things that you mentioned are provided by Flink out of the box.
So what's the advantage of using Beam if you are already using Flink? Okay, so it's portability mainly. Okay, so if tomorrow you want to move away from Flink for whatever reason, so you should be able to move to other runners that have the same level of functionality, like for instance Dataflow. Okay, I don't know, like think. So we have one of the main committers here of Apache Flink say that he get hit by a bus. Like let's say we don't want that to happen. Okay, but that may happen. Like everything may happen. Okay, so you know the world is really very uncertain. Okay, so basically you have portability. Okay, yes.
Thank you very much. Unfortunately, we don't have time for more questions right now, but I'm sure you will be happy to answer it.
Yes, anytime. Yes, thanks. Thank you. Thanks.